Welcome back. This is video 2 of chapter 6, and we're going to start at 6.4, and we're going to talk about sending data into a function. Now, we've already done this in our examples. If we look back to the add numbers, we put 2 and 3, and we sent that as parameters. But let's talk about it a little bit more detail. So you can pass values into a function at the time of the call, and that's exactly what we're doing here. We're passing numbers at the time of call. So here we're calling the function and we're passing in some values. Values passed to a function are arguments, and variables in a function that hold the values passed as arguments are parameters. So the reason why they're explaining that is, let's go here. Values passed to a function are arguments. So this are arguments, just like this is. These are arguments. However, variables in a function that hold the values passed as arguments are parameters. So again, back to our little test code here, these are parameters. Same thing with this. So these get passed in. 9 gets to the first one, and then 4 gets to the second one. A function with a parameter variable. We've seen this. In fact, we're saying here this this function, display value, it has an expected incoming parameter of int, and num is going to be the variable that's used inside the body of the function to represent the passed in int. So in our example here, we've got a function and this is a prototype. Make sure you understand that, because our actual function is down below. It's on the next page, right? So we'll get there in a second. But this display value, it now knows about display value because we gave it a prototype, and it's going to pass in 5 as an int. Now, before, if you look at my areas, I actually went ahead in my, this is the wrong one. In this one, I went ahead and gave the names too. You don't have to. And in fact, in this, you can see in this prototype, the int is all by itself. It's not giving it a name because there's no body. So the compiler doesn't care. It just wants to know what are the expected incoming data types. So this is that display value that it's calling, and here's the actual body, and it's outputting the num. And so now, because we need to know how to use that, we do have to supply the name of the incoming parameter, and so that way we can use it. This is the example that they just had where we're passing 5 into num. Now, like everything, we always have to make sure that everything can be called by multiple names. So that way, for some reason, we can make it a little bit more complicated. But I will be honest with you, most people don't call a parameter a formal parameter or actual parameter. They just call it a parameter. And same thing with argument, formal and actual. But these are terminologies you may hear from time to time. And they are legitimate names for those pieces. We've been talking about this, and we're just kind of going over it again because it makes sense to really hammer this home. And that is, remember, we've got prototype, which has got the, it does have to distinguish the incoming parameter type. Then we actually have the header, which is going to be right above the actual function. And, the function is going to be below this. And then we've got the call, which this is where our code is running, and at some point we want to call this actual function. So in our code, we're going to call the function, and we're going to pass in the incoming parameter. Now, you can use a literal, like this one is an int, so we could say 5. Or it could be a variable, let's say x1, which we, previous to this, have already assigned it. I didn't mean to delete everything, but this could be x1, which somewhere above our code, we could have already assigned it a value, or maybe we're pulling the value from the database, what have you. But we can put variables that have that are the same type in here in the call, and then that data will get passed to the function. So function call notes. The value of the argument is copied into the parameter when the function is called. We're going to talk about that here in a moment. This is known as by value. And when you are dealing with primitive types like integer, boolean, things like that, they are known as by value types, and they will copy into the function as their own data type. We'll see that here in a moment. A parameter scope is the function which uses it. Let's talk a little bit about scope. One of the things I'm going to try to start hammering in is scope is basically from curly bracket to curly bracket, right? So main scope is from here all the way down here. Anything that is variable that's created in here can be used in this scope. If you create a variable in here, you can't use it in this function scope without passing it in as a parameter. So if we set up the, like here we have the int x3, I can't call add numbers and expect that it just knows what x3 is because there are different scopes. When it comes to scope starts at the curly bracket for the most part and continues all the way down. Now, if there is, let's say, sometimes we have, let's say, ifs or fors. Let's say in here we had a for loop. And then it has curly brackets. Any variable created out here would be able to be seen in here. So the variable could be seen in here because this set of brackets is inside of these set of brackets. So it can go inward on brackets, but it cannot go outward. And what I mean by that is if we had a for loop in here, so let's say we had a for loop right in here. We're going to just say for. And in our for loop, we set up another variable. Let's call it int y. Well, the for loop knows about x1 and x2 because it's in the brackets above it. The outer code, when I get back to this line of code, would not know about y because y cannot go out past the end of brackets. So this does not happen. We can go in to brackets, but we cannot go out. So that's something to kind of remember. This is one of those pieces that can be a little hard to digest, but that's what scope is. And because this bracket is not inside this bracket, they don't share scope. And so anything that's known here is not known here. And vice versa. Anything in here, like this return x, cannot be used down here because this function knows nothing about return x. Function can have multiple parameters. Well, we've already seen that. We have one right here, x and x2, x1 and x2. Yep. There must be a data type listed in the prototype and an argument declaration in the function header for each parameter. So all they're saying is, hey, if you want multiple parameters, they have to have not only their data type but their the name that you're going to use in the body. Arguments will be promoted, demoted as necessary to match parameters. So here we have an int x. If I had tried to pass in a double, more than likely the compiler would try to shrink that into an int. It may give us an error. It may also cause programmatic problems because a double is bigger than an int, and we might try to shove too much data in there, oftentimes known as a buffer overrun. If we had doubles up here, so if this was double, while we're passing in ints as literals, these are going to be seen as literal ints. And then down here, we're actually setting up ints and passing ints in as variables. This should still work. That's because the compiler is smart enough to go, hey, an int is smaller than a double, so we can easily make that conversion without really losing any data. So go ahead and just do that. All right. Passing multiple arguments. When calling a function and passing multiple arguments, the number of arguments in the call must match the prototype and definition. Well, that makes sense. Again, if you're going to be setting up a prototype, whatever's here is going to have to match here. Now, the only difference is we don't have to declare the names. We can do just that, and that would be fine. As long as there's two ints here, there's got to be two ints down there. The first argument will be used to initialize the first parameter, the second argument, and so forth and so on. That's pretty straightforward. I mean, if you've got three ints, and you're going to take in three values and then pass them, value 1 is going to go to the first int, value 2, and so forth and so on. And here is a nice little display of that. So passing data by value, this is the thing that I said we would get to and talk about a little bit about. And when we're passing data by value, and please understand, this is something that can take a little bit to understand. This is less difficult to understand when we start talking about passing data by reference rather than by value. That can get even more complicated, and we're going to cover those things. But right now, let's just talk about passing by value. And that means when an argument is passed to a function, its value is copied into the parameter. And it has to do that. And the reason why is we just talked about scope. With that, you're going to see that if, like, for example, A1 here, well, A1 can't go up in here and be part of this function because it's not in the scope. They're outside of different scopes. So what happens is because this is an integer, it's going to pass the value up here, and then x1 is actually going to be a duplicate of what A1 had. So if A1 has 5, x1 will also have 5, but x1 and A1 are not the same variables anymore. X1 is its own variable, and in fact, if I were to change x1 in this function, it does not change A1 at all, because x1 is its own variable at this time. That's what's known as passing by value. The value itself gets copied into the parameter list for the function, and changing those numbers will not edit the numbers being passed in. So changes to the parameter in the function do not affect the value of the argument. So example, if we have an int x5 and we're doing the even or odd value, we're passing the value of 5, which is a literal, right? We have a literal here, and we're putting that literal right up into val, and now we're passing val, which is still technically under the hoods a literal. When it gets to the even or odd parameter, which is num, if you remember from previous slides, all of a sudden num, which is part of the even or odd function, also has its own 5. When I change this, it will not change that. We have an actual copy of the value. Now, with that being said, let's talk a little bit about using functions in menu-driven programs. Functions can be used to implement user choices from menus and to implement general purpose tasks. So we keep doing this kind of menu-driven program logic. It's one of the kind of the first things that most people do as they get a little bit more into programming. You want to make to where the user can choose from, hey, do you want to do addition, subtraction, multiplication, or division? Those kind of menu-driven items. If you think about your daily use of applications, most of a lot of what you do is menu driven. So this is why we keep talking about it. And what they're saying in this is now you can use functions. Before we were using case statements in our case statements, or we were using if else statements, and the code for each menu would be in the main under the correct case statement or under the correct if statement. Now, instead of doing that, you can use the if else's to figure out what the user has asked for. But from there, you're just going to call a function that actually has all that code for that particular menu item in it. Now let's finish this video with talking about the return statement. The return statement used to end execution of a function. Now, we've already talked about voids. Voids mean nothing is going to be returned. When your function runs out of code, it's automatically going to say, hey, return. It does it for you. If you have a void and somewhere in your code you want to say to go ahead and exit out of this function, you can too also just use the word return. So when I do this, this cout with test will never ever get hit, because when it does this first cout, it will return before it can get to that second. Oftentimes what happens is if error flag, right? So we set up an error flag. If for some reason somewhere in our code an error flag turns to true, then we could tell it to stop doing the rest of the function by doing it this way, saying if and return. Now, because it's a void, we're just using the word return, where here in main, it's an int, so we got to return an actual value, like int. So that's the difference. In a void function without a return, the function ends at its last bracket. One other thing to know is if you have a function that has a return, if you do not specify the return, you will get an error, because it can't just derive its own. Oh, and it's funny it must be returning 0. It used to in previous C++, and also again sometimes these online compilers do a little bit of help for you. So understand that if you don't do this return statement, usually this causes an error. But I think our online GBD is helping us a little bit here. So a quick little example: we've got the main. Again, we have that return 0 that tells the operating system that there were no errors. In this, we have a void, the divide, and here's a great example. You can't divide by 0. So if arg2 is 0, 0, then we should put out there, sorry, I can't divide by 0, and then return, because we don't want this line to be ran anymore. Now, we could have said else in this, but this is a great example of when you're just going to kind of return out of the function. All right, so that's it for this video. The next video, we'll start talking about returning a value from the function. So we talked about here a little bit about return by itself, especially for voids. We have talked about returning values a little bit already, but on this next video, we're going to start by jumping into that and talking about that a little bit more. We'll see you there.